Hello everyone. So we are back in the design series and today we are going to see the visitor design pattern. So what is a visitor design pattern? It is a way to separate the operations from the object on which they are operated. It lets new behavior to be added to an existing object structure without modifying those objects. So this is a simple design pattern where you can add new behavior to an existing object without modifying them or without changing them. So the object is a kind of element which holds the data and accepts the visitor. So it is having a method called accept, mostly called accept, basically you can say. Whereas a visitor contains the logic or the operation that you want to apply. So let us take an example and try to implement how we can implement the visitor design. I'll create a file, visitor.cpp, hash include iostring using namespace std. So we are going to take an example of a directory system and we'll try to print the size of the directories. So the first class I would be making is a visitor interface. So I'll just write it down. Visitor interface. So class visitor. So why am I taking a visitor interface? Is because I want to have certain predefined methods. So I want to specify like the visit method is going to take certain arguments. The parameters are going to be fixed. Public virtual void visit. And the first one is the method which will be taking the file as an argument. And the second one is virtual void visit directory dir. So I'm also going to make a destructor over here, visitor, which will be default. Then since I'm using the file and directory, they will be the classes that I'll be making afterwards. So I'll just have a forward declaration, class file and class directory. Right. Okay. Is there any spelling mistake? No, it should be fine. Okay. The second thing I would like to have is the element, which is a kind of subject. So element interface. So this will be a class, say file system element. Now inside this, like I said, I'll be having a method called accept. So we'll be having virtual void accept. It will take a visitor as an argument, right? Because we need to identify what kind of visitor are we getting. So I'll make it pure virtual. Then we need a destructor, file system element. We can leave it or we can assign it to default. Now, once this is done, I need concrete elements. So this was the concrete interface. Now we need a concrete element. So the first one is the class file, which will implement publicly the file system element. And in the same way, we will be having a class directory, which will implement the same file system element. So let us complete these first. So the first thing is I would be having a name for the file. There will be some size of the file, and inside the public section, I'll be having a constructor, say file, and it will take an argument string n and one int size, let us say, and I'll just assign it to the variables where size assigned to s, right? So after this, we will be having some getters like get name and get size. So I'll be having string get name. I can make this as a constant function, return name, and we'll be having get int get size. Again, we can mark this as constant method because we are not going to change anything inside the class. So just return the size. After this, I'll be having void accept visitor. So I'm going to override this method from the file system element. And it is going to be very simple that since we are in the file, so we'll be calling the visit of the file, right? So I'll be calling v dot visit, and inside the visit, I need to pass the visitor reference. So how am I going to pass the visitor reference? So I can dereference this operator and I can pass it to it. So this way I can implement the accept method. Now the same thing applies to the directory also. So again, we'll be having a name of the directory. Then we'll be having say a list of childrens that we'll be having. So I can keep it a vector of file system element. Now inside the files is okay, it will be a pointer. We'll mark it as a pointer. Children, right? After this, inside the public section, first of all, I need a constructor. It will take the name and I'll assign the name n. After that, I will be having some get name function, a getter. We can mark it as a constant function as well. Return name less. Let us mark it constant as well. Now, after this, I would have an add method to add the certain pointer of the element into the children. So directory can have multiple files or subdirectories as well. So void add, I'll be having a file system element pointer, say element, and I'll just say children. Okay, children is not visible. Okay, vector has not been imported, that's why. So I'll just say hash include vector. So there's children dot pushback, and I'll push the element inside my children. Now I also need a get children which can return me the children list. So these are just certain getters and setters. I'm not using default like tools to generate the getters and setters. So void, okay, it will not be a void. The get children, we have to return a vector of file system element pointer, and we can name it as get children. Again, we can mark it as a constant function, return children. Now, after this, we have to implement we have to override the accept method. Void accept visitor reference v. And again, I'll be calling the v.visit, and I'll pass the reference of this. After this, I would also need a destructor over here directly. And inside this, I'll just apply for loop auto say child, and I'll traverse through all the childrens and I'll say delete child. So over here, I can just return the reference of it. Okay, so maybe we can avoid the reference over here as of now. Maybe it is a constant function. So after this, since we are going to return the child size of we are trying to calculate the size. So we'll be having a class size calculator. Now, the size calculator is a kind of visitor. So I'll publicly implement visitor. Inside this, I would be having some total size, which will be initially 0. And after that, in the public section, I'll be having visit method, void visit, and I'll take a file reference file and I'll override it. Since we have two visit methods, one with the file and one with the directory, I'll just say total size plus equals to file dot get size. So the getter will be getting the size. Then again the visit method, but this time we'll be using the directory reference dir override. And this time we'll be traversing through all the children's. So auto child, then we can call dir dot get children. And over this, I'll be calling child except. And inside except, again, I'll be passing this. So this should work. Okay, this is a method. So we have to call it. Right. So if we want to get the total size, then we need a getter over here, total size. And again, we can make it a constant function. We can return the total size over here and make it a constant method. Now, after this, we are just left with the implementation of the main method, and we have to see how we can make use of it. So we have int main. Now inside int main, I'll create a directory, say root, new directory, and I'll assign some name, say root. Inside this, I'll say add new file, and I'll pass some name, say file1.txt, and its size is 10. Root add new file, say file2.txt, and its size is again 10. I'll create another directory, which is subdir equals to new directory, and I'll pass a name, say docs. And this time I'll say subdir dot add new file, and I'll pass, say resume.txt, and I'll pass a size, say 20. Okay, we have to use arrow operator over here. Now after this, I'll say that add the subdirectory to the root, and let us make it slightly more complex. So root add subdir. So now our subdirectory is inside the root. So if I want to calculate the size, I'll just say size calculator, size visitor will be there. And inside this, I'll say root accept, and I'll pass the size visitor. Once the size is calculated, if I want to print it out, I have to say the total size, and we have the size visitor that we have created. Over that, I can call get total size. Let us say it is in KB. And we'll just return 0 over here. Let us try to save it and run it and see if there are any errors. G++ visitor show visit. So it compiled successfully. If I'll try to run it, we can see the total size has correctly been printed, which is 40, 10 plus 10 plus 20. So this is how we implement the visitor pattern. So it is sometimes used, but not majorly used in system design questions. But it is good to have the knowledge how we can implement the visitor pattern and in what cases it can be useful. So we'll be coming up with more videos, and soon we are going to start with the system design questions, and we'll look on to them into depth with all the heading functionalities as well. So if you have any doubts, you can ask in the comment section.